In this section, we'll take a look at some topics that I've reserved for later. Not because they're not important, but because I could reserve them for later. In building this course, what I found is that everything I want to teach you wants to happen on day one. And so the principle I've adopted is that if things can't justify being on day one, they have to go on day two. And the things, in fact, start from the end of the week and then they work forward. So what we've got here is a sampling of some of the topics I want you to get some feeling for, and that's what section 1 is all about. Take a look at memory management. You've got to be able to allocate and manage memory, and to do that successfully with the 2 window memory managers. Take a look at data exchange, how inter-process communication is performed within the Windows environment, and in particular, how the clipboard and dynamic data exchange mechanisms work. We'll look at how you can open and use files. It turns out there is a single call in Windows that makes it easier to handle floppy disk changes and so forth. Then we'll look at what I think are some very advanced and very interesting topics, just to send you off with a hint of some of the richness that we haven't had a chance or time to explore during this course. First thing we'll take a look at is scrolling. How do you handle the fact that many of the documents your users work on are much bigger than you can put into a window that they give you? And then I'll show you what you can do with Win.Ini. Win.Ini is the place you can store data so that when you retrieve your programming again, when the user starts up your programming again, you can start up where you left off. In this module, we'll take a look at the Windows 2 memory managers, the global and local memory managers. Then I'll have you go off to the laboratory and actually write code which will allocate and deallocate and use both global and local memory. Windows provides 2 memory managers. We referred to this earlier. One is a local heap memory manager. There is a single local heap per program. Every time the user runs a copy of your program, part of the instance data that you get created with, in addition to a task queue, is a local heap. The other manager is the global memory manager. That's used by all of the customers of Windows, that is all the Windows programs running at one time, and by Windows itself, to manage all of memory. Both of these memory managers provide you with the opportunity to allocate and deallocate memory. In addition, there are also calls that you can force Windows to take all of the movable objects and compact them. In case, for example, of memory fragmentation, we need to be able to move objects, compacting them so that we can reclaim a larger single block of free storage space. The local heap is reached through the DS CPU register. That means that anything in the local heap can be accessed as a near value. You're guaranteed that DS is always in place when your code is running. It is true, on the other hand, however, that the local heap is limited to a maximum of 64K. In fact, it's actually a little bit smaller than that because there's some magic data that goes right down at the bottom of your data segment and takes a little bit out of your local heap. In fact, most applications include the stack segment in the same data area as the heap. That further shrinks the amount of storage available for your local heap. Thus, the sum of your stack and automatic data and your local heap is limited to 64K. But the local memory manager is very useful because it's reachable through newer addresses. It's very quick. It should be used for objects that you've got that are fairly transient. You can use them and throw them away. The global heap must always be reached through far addresses, full addresses. You have no idea how far away such an object can be. It does, however, cover all of memory. One of the additional finesses that we have added to the product for Windows for DOS version 2 and greater is the ability to work with memory above the 1 meg boundary through the EEMS, or the LIM 4.0 specification. That's a fairly advanced topic, but it does affect the flags that you specify when you allocate global memory. I'll refer to that a little bit later in another lecture when we talk about dynamic data exchange. Each of these memory managers has its own set of API. For example, there is a local alloc function and a global alloc function. Notice that these allocators return to you a handle. They don't return an address. In general, when you allocate a movable object, which is highly recommended because fixed objects can cause memory fragmentation, you then need to take the handle and do a local lock on it or a global lock on it. Windows will pin it into memory at that point, fixing it in place so nobody will move it around, and then return you an address. And you can use that address then. A near address for your local objects and a far address for your far objects. Remember that leaving objects locked will cause memory fragmentation. This is true in both the local heap and in global heap. In fact, one of the activities we constantly pursue in the Windows development team is working on the algorithm of where does movable, discardable, swappable, fixable, non-fixable, where do these things go out of global memory? Because it makes a great deal of difference to the throughput and the management of the system, where things go. When you're done with an object, unlock it. Unlock your local objects, unlock your global objects. The handle will still remain the handle. The handle will always refer to that object. But you will invalidate the addresses when it's movable. Be very careful about preserving any addresses at a time when the object the address is supposed to refer to is unlocked. We reserve the right to move it. Now, there are only a few times when things actually can get moved. In general, though, there are enough of them that you need to be very, very careful with unlocked objects and to mark those addresses as essentially invalid. There are a number of flags that you'll use when you do local allocation or global allocation. They have to do with whether you want it zero initialized and so forth. Those flags you can study. But for now, that's pretty much the introduction that I want to give you about the memory manager. Remember, you allocate memory, you get a handle. You lock the handle, you get an address. That address you can use. It's just another address. And you can refer to it and use it as the address of a data structure to get at pieces of that storage. When you're through with it, unlock it. And, whenever possible, allocate local and global memory as movable. With that background on the two memory managers, you're ready to go and actually do a lab. What I want you to do in this laboratory is to allocate some local and allocate some global storage. Take one of your strings and write it out there. Pull it back and use that string on your client area to prove to yourself that you've been able to successfully allocate and use that memory. There's not a lot to be done. I mean, it's really hard to see what's going on in the memory manager, but I want you to get some facility and an understanding of those API calls. I'll see you when you're done with that. In this module, we'll take a look at the various mechanisms provided within Windows for you to exchange data between copies of your program or between your program and another program. While there are a number of mechanisms, in the laboratory, we'll simply have you use the clipboard to store and retrieve text and bitmaps and metafiles. Windows provides a number of mechanisms with which you can perform inter-process communications. These include the Windows clipboard, shared libraries, dynamic data exchange, and then simple Windows messaging as well. The clipboard is a built-in part of the Windows API. Because of that, it is available to you on any system running Windows. But the other aspect of the clipboard is that it's primarily there for the user to move data between applications. in particular, where you may have a clipboard interface to receive or transmit information to the clipboard, you will also need a user interface so that the user can specify what it is that should be moved to the clipboard and can paste from the clipboard into your application. In general, our clipboard holds one item at a time, but it may be that you've got several forms of the data. For example, you may have a spreadsheet which you have stored in some high-level format of your own. You might also have a text rendition of that spreadsheet, and conceivably you might even have a bitmap representation. You can install all three representations of the same piece of data into the clipboard. The user, or the consuming program, that is, the program which then takes the data out of the clipboard, would choose which format was the highest level it understood. That's a matter for the consumer of the data to decide. There are other mechanisms in the clipboard API that allow you, for example, to delay actually providing the data until a time which is more convenient, and so forth. In use, the clipboard would be used in much this fashion. For example, say that I'm writing a document using the notepad, and I come to the point where I have an arithmetic expression, but somehow I've forgotten what 324 times 45 is equal to. What I can do then is to clip or to copy that string into the clipboard. At this point, I have text now in the clipboard. If I go to the calculator and paste those characters into the calculator, it's just as though I press the buttons one after the other, and now I have the result in the calculator. I can go from the calculator, paste the result back into the clipboard. How about it? I can go back into the calculator and copy this result into the clipboard, then go back into my document, move the insertion point, and paste the result of the computation back in. In this way, users are able to move data between applications. Your applications must provide the cut, copy, and paste mechanisms as part of the user interface. And you must also be able to allow the user to identify the data which is going to be moved. It's typically called a selection. If you find that our clipboard is not sufficient for you, it's also possible to move data into a shared library. You could write a library of code and then distribute that library, and that library could serve as an additional or an extension to the API which is part of Windows. Now there's some problems with that in that you have to get other people to agree, but if you had a family of applications that needed a more complicated clipboard functionality than is provided in Windows API Clipboard, you could write your own library and distribute that with your applications, and that library could handle moving and holding data for you. An even potentially more interesting mechanism is the dynamic data exchange mechanism. Now, in the past, I've been asked, how does this differ from pipes and queues? And I mean, given that, for example, operating systems like Unix have been enhanced over time with the addition of new IPC mechanisms, what's in the user for the fact that we have the capability of sending messages and the dynamic data exchange? Now, my claim is that this is really a fundamentally different mechanism than those which are part of the typical operating system. I mean, if you think about it, the only way to connect to a pipe is to know its name. The only way to connect to a queue is to know its name ahead of time. These things are fixed, if you will. What the dynamic data exchange mechanism allows is a broadcast. It's based on the Windows Send Message function and a protocol which we have defined for using that function in transmitting data between applications. The DDE mechanism is a request, server-oriented kind of mechanism. And the best thing about it is when a requestor decides that it needs a piece of data, it can broadcast everything in the system. And it can say, look, I really would like to acquire the following data. Maybe it's old stock market reports, or maybe it's old traffic or weather reports out of some database that is known to be available. By broadcasting the message to all Windows programs in the system, Your application, or the consuming application, can establish whether or not there's a data provider available in the system. And in fact, it is the responsibility of the data provider then to return. What happens then is through the DDE mechanism, the server and the requester establish a connection. And in point of fact, it's even possible for that connection to go through a LAN. That is, there's no reason that the data server must be resident on your machine. It's certainly true that you have to have a Windows program that behaves like a server. But when I broadcast from my Windows program to all the Windows programs running in a PC, if one of them says, oh yeah, wait a minute, and it knows how to talk through the network to the actual provider, it can arrange to return the data. And to my program, it's absolutely transparent that that fact has taken place. So DDE is a very helpful additional mechanism beyond those which were originally conceived in Windows. It's a protocol based on the messaging capabilities within Windows, and I claim that it's fundamentally different than the standard operating system techniques. It's fairly complex, however. I expect that you'll want to read about DDE, and as you get into comfort about messaging and so forth, want to use it. But let's take a look at what I think you can do at this point in your lab. I'd like you to go off to the laboratory and write some code to use the clipboard. You've worked with text strings, you've worked with bitmaps, and you've worked with metafiles. And now what I'd like you to do is to add a user interface to your program that allows you to clip and retrieve data. What I've done is to run 2 copies of this application. You'll notice it's fairly heavily modified from the Shapes program, which is part of the Windows SDK. I'm going to clip some text from one application and paste it now into this other. I'm going to go back and I'm going to put a metafile into the clipboard, and then first let me make sure that you see this is a lip, an ellipse. Now I'm going to get that metafile and play it into this new application. Finally, I can put some bits. I've selected just 100 by 100 bitmap, and I can then retrieve that bitmap. Oops, a little hard to tell. Let me draw that ellipse again and get the bits from the clipboard. Now what would happen if I try to get text at this point? After all, the clipboard contains a bitmap. If I try to get text, I'll get an error return, and I put some message boxes in here to let me know that that's what's going on. So these 2 applications are just 2 copies of the same application, and in your lab, you'll be creating something very similar to that. Go ahead and do that, and I'll see you when you get back here. Well, now that you know how to manage various pieces of Windows, you can allocate memory. The next thing you're going to be able to do is to do some file accessing. At this point, let me talk to you just briefly about the file management capabilities within Windows, and then I'll have you go off and actually use a little bit of filing within a lab. There are a couple of major points to remember about file access from within your Windows program. One is that there are other Windows programs running. It's therefore very important that you should open a file, get the data that you need, and close that file, and try to keep those file handles closed. Furthermore, you might be running in a 2-floppy PC. Some users still have those systems, or a user may be using a data diskette, for example, even while the program resides on hard disk. In cases like that, user using several programs may in fact have several different diskettes that they're working with. It's very important, therefore, that you should have a mechanism which allows the system to prompt the user to replace your data diskette when they say move from another application into working with your application. There's a single call in Windows which is very, very helpful in this environment. That's the open file call. Open file can be used to create or open, and in particular to reopen files which you've been using. In the event that the diskette currently in the drive that you expected to find the file in is not the diskette that was there the last time you looked, open file includes functions and capabilities to prompt the user to replace the diskette, which needs to be in place for the file to exist on that drive. You should use open file whenever you're opening a file. But once the file is open and you've got a valid file handle, go ahead and use your CIO runtime routines. Notice that the CIO runtime routines are not shared libraries, but rather it's the same regular old C code. It's going to get linked into your program and be part of your program, to be resident within your program. It's very important then that you use CIO routines to perform seek and rewind and reading of files, and that you recall that that code will be linked into your code segments. In order to support your use of temporary files, there are two calls within the Windows environment, one to return to you the drive letter of the current drive on which the temporary directory exists, and the other to get Windows to help you cobble together a temporary file name. Two functions are provided which help you with that work. Again, the most important thing to remember about file access is that other programs may be running, and other programs may be accessing the same file. You may be running in a DOS 2 or 3 environment in which file protection is not yet a part of the operating system. It is therefore absolutely critical that you should open a file, get all the data that you need into, say, RAM, and then close that file so that if the user were to go off and schedule another application by working with it, that the file could be reopened by that other application safely. Users will, of course, discover if they have two apps, they're both trying to write to the same file, but you need to remember, open file is the call you use to open a file, and open file is the call you use to reopen a file. I want you to prepare now to go back to the lab and actually use the file. I want you to open a file, read a file, and use it. When you're able to do that, come on back, because then we'll be ready to actually access enough information that we can scroll something in a window. Once you open up a file, you're very likely to have more information than you can display to the user in a window. That brings on the need for scrolling. In this module, we'll talk a little bit about scrolling, and then I'll have you go in and add a scroll bar to your application and scroll around in a file. Now that I've showed you how to open files and you gained access to files, you probably discovered that a lot of the time you'll be working with documents which are larger than or can't conveniently be displayed in the window that your user gives you. In that case, you're going to want to add a scroll bar or two so that the user can navigate around in a file. In this example, I'm going to examine the file simple.c that I suspect you're fairly familiar with by now, and use Notepad for that purpose. You can see that this application has got two scroll bars. It's got a vertical scroll bar and a horizontal scroll bar. Each of these scroll bars is equipped with 5 sensitive areas, if you will. There's a left unit at a time, a left page at a time, a right page at a time, and a right unit at a time. And it's up to you to decide what a unit is. If you're a text file, typically it's a character horizontally and a text string vertically. If you're in a graphics application, you might move an inch or some number of coordinates in either direction. The user can also grab the thumb, which is this little elevator thing, and move that around directly. So there are basically a number of different things that the user will indicate to you that they want to do. Scroll bars are added to a window when it's created. They are, in fact, window styles that are added to by ORing in with the other window style bits. Turn them on and off by adding them at the time the window is created. Once a window has a scroll bar, when the user operates with a scroll bar, Windows takes on all the responsibility of drawing the scroll bar on you. But you will get new messages. In your window procedure, you will get a message when the user works with the horizontal scroll bar. You'll get a message when the user works with the vertical scroll bar. In general, what you will get is a message identifier of either WMH scroll or WMV scroll. Those two new messages come along with 5 sub-messages so that you can tell whether, for example, the user has pressed the line down or the line up button or the page down or the page up areas, or has in fact grabbed the thumb by clicking the mouse button and dragging the thumb around on the scroll bar. You can reposition the scroll bar at will. You can change the coordinate range of the scroll bar. And all of this is sent back to you through the window procedure. Now, when you get a message, for example, that the user has gone line up, a lot of the information on the screen remains valid. The scroll window function is provided for you to help you move and preserve bits on the screen. What you'll get then is a message lying down. You'll think about it for a while. You'll decide how to move the area and call the scroll window function to get it to move a block of bits from one place to another. In that way, you can support doing minimal replacements of, say, just a new line, and so forth. Well, scrolling is not really simple. We saved it for last because you have to be able to access files to get something big to scroll around on, and there are a lot of other capabilities that you need to understand very well. But at this point, you're prepared to go off and do a lab on scrolling, so let me tell you about that in a minute. What I'd like you to do now is to go to the laboratory and actually use scroll bars. You're going to take your application and add to it the ability to browse on a file. In this case, in fact, I'm browsing on the file which is the C code for this particular application. In this module, we're going to take a look at win.ini. Win.ini is a kind of an interesting way to extend for your users more constancy across the times when they use your application. We're going to talk a little bit about win.ini, and I'm going to have you go into a laboratory and actually use the win.ini file to preserve the coordinate locations of where your window was the last time the user opened your application. One of the great things about the graphical user interface concepts that are embodied in Microsoft Windows is the extent to which the user can tailor the system, and that the system remembers the way it's been tailored. For example, there are entries in the win.ini file relative to preferred screen colors and menu colors, preferred country settings, for example, how you want dates displayed or time displayed. A lot of other things can be stored in win.ini. In fact, there are some API functions which you can use to set values in win.ini and retrieve those values from win.ini. Those functions, therefore, allow you to enhance and add value to your graphical user interface applications by actually saving some state. For example, one of the things you might save is the location of the window on the screen at the time the user last worked with your application. Another thing you might save would be some of the state of the palette. What are the attributes? What's the current pen, the current font, and so forth. And you might restore those attributes after the user has reinvoked your program. Whenever you use win.ini, you're going to be able to preserve state for the user across invocations of your program. It's a fairly new concept to be able to do this. We've done it for quite some time in a lot of our applications. But I think you'll find that the win.ini file is a great place for you to begin to work with saving the kind of state and beginning to conform your application to the way your user works with it. We've got a lab for you to do as well. Talked a little bit about win.ini and how you can use it. Let me show you how you can use it. Now in particular, what you've been seeing is kind of your horizontal indicator of where you are in the course is this Windows application. There was Section 1, Section 2, now we're working with Section 7. When I pull down the menu About, and I get up a dialog box, for example, telling you that the lab objectives this time are going to be to use win.ini to preserve the window coordinates, what I've done is to actually do exactly that. If I change the size of that window and close it, my program goes off, stores the values, the coordinate locations in win.ini, and the next time I invoke the dialog box, it comes back to exactly where it was. That's what you're going to do in this lab. I'll see you when you're done with that.